So, whoever is trying to solve this problem, I have bad news for you. This has no easy solution. The only way to actually solve this is to use sine law and cosine law repeatedly, right? That's the only way to solve it. There is no angle chasing that you can do, there's nothing. And by this point, you must have also realized that angle chasing doesn't lead you anywhere, right? You just go in a circular loop and it's not fun, right? You spend hours trying to do this and then you realize, okay, it's not solvable using the methods that we know. You will have to think of something else, right? And that something else is just sine law and cosine law. So the way to do it is you assume one of these lengths to be 1 or anything that you want, but I'll just say 1 because it makes everything easier. So you can just scale up the whole figure, right? And that's why you can choose whatever length you want. So if this thing is say 1, then you can use sine law for this triangle, right? And from that you can figure out what this length is and what this length is. Cool. Then you can use sine law for this triangle and figure out what this length is and what this length is, and then for this one as well. So now you know all the lengths, right? So you also know what this angle is, right? It's just 180 minus p minus q, and yeah, you are ready to go for the last triangle. So you know what this angle is, you know two of these lengths. Call these unknown angles as some variables and then just use sine law once again, right? So oh yeah, but before that, in fact, you need what this length is. And now how do we get what that is? Because we don't know what these angles are, so we can't use sine law to actually get what this is. But there is something else that we can use. It's cosine law. So you know what this length is, what this length is, and what this angle is. Just use cosine law and get this side. Once you know what that is, you're good to go. Just use sine law for this smaller triangle and you will have your unknown angles. So please don't spend time on trying to find a good solution for this. It's not possible, right? Now how did I get to this conclusion? Why did I start doing this problem? So I was looking for a way to prove that the so-called cyclic quadrilaterals that would be cyclic quadrilaterals if you use the converse theorem that the opposite sides add up to 180 degrees, then it's a cyclic quadrilateral. So I was trying to prove the fact that if the opposite sides add up to 80 degrees, sorry, 180 degrees, then these two angles would be would be equal, and similarly these other angles would be equal, and so on, right? So that theorem is actually very hard to prove without the circles involved in it. So you have to first of all use that theorem that if the opposite sides add up to 180 degrees, then you can actually have all of this in a circle and then use the angle inscribed theorem and all that stuff. So that's the only way of doing it. This path of actually finding out what these two angles are, right? That's when you would find this out without the knowledge that the opposite angles add up to 180 degrees. You would just find them out, and then you would use the knowledge that the opposite angles add up to 180 degrees, and then you would have some kind of a relation, right? So don't try to do that. I tried it and it was not good. Just yeah, that's all I want to say. So I'll see you guys in the next video.